All right. To graph a polynomial function, what do we need? We need to know n. We need to know a. We have to find the y-intercept, and it's always the constant term. We have to find the x-intercepts. And we have to find some points. Okay. We know the shape by looking at the leading term. The leading term of the polynomial is this. The leading coefficient, if it's positive, it's an increasing function. If it's negative, it's a decreasing function. Now let's look at some more about the degree. The degree is n. This tells us the maximum number of x-intercepts. It tells us the direction of the ends of the graph. Also tells us the maximum number of what are called turning points. So the maximum number of x-intercepts is n. The maximum number of turning points is n minus 1. What are turning points? Those are the points where it stops increasing and starts decreasing. It's the vertex. Or it starts from going decreasing to increasing. That's the turning point.
So
Right.
how is that
Now,
different from a vertex?
well, it's the same thing. It's just it's either the vertices. But see, now they're given different names. Because vertices work whenever we're dealing with maximum or minimum. Turning points deal with when is the slope changing from positive to negative. It happens at that point, which is the vertex, the local maxima or local minima. So if a slope is decreasing to increasing, that's the turning point. So that's what we just changed the name of it.
Awesome. Sounds good.
Okay. To be honest with you, with this section, what I've told you already in the first section is a lot more simple than what they're trying to show you here. I'll show you what they're trying to show you. Here's our function, negative 2x to the fourth plus 3x cubed. Either way, we have to find the x-intercepts. So in this case, how do we find the x-intercepts? Well, can we factor anything out of both of these?
No, because the exponents are different?
Well,
Or is it
that's it.
x?
No, because this one has 4 x's, this one has 3, so they both have at least three x's that are the same. Because the x's are the x's, yes, even though they're not same, we can't combine them like combining like terms, but when we're factoring them, we can take out three x's out of both of them, which leaves us 2x plus 3. So I took out the three x's. Follow me so far?
Yep, makes sense.
Okay, now it makes a lot more sense now because we also know, what do we know about this graph? If we were to just to sketch this graph, well, what do we know about it? What's n and what's a?
A would be 1.
Mhm.
Oh,
A is whatever's in front of the highest exponent, so it's -2.
oh, I was looking at what we just wrote out. You're right. And so n would be 4.
N would be 4. So what does this tell us about our graph?
In this case, it would tell us that since n is even, it's
Mhm.
both ends are going up. Wait,
The same direction.
yeah, same ends, same direction, but since a is negative,
They go down.
down, yeah, decreasing. Okay,
Yeah, so the N just tells us if they're the same directions or opposite directions, and A tells us whether it's up or down.
got it.
So,
Okay.
so we have to know what our x-intercepts are. We take both of these functions, set them equal to 0. So x cubed equals 0. Only way that's possible is if x is 0. So we have an intercept there. And we have 2x equals 3, or x equals 3 over 2, which is 1 and 1/2. Since the degree is 4 and a is 2, they both point the same direction. They both point down.
Hey, wouldn't the solution to our second one be like on the second step, wouldn't that be -3 since we're subtracting 3?
Yes, but then we had a negative in front of the 2.
Right, so we change the signs.
Change of signs.
Okay,
Yeah, what I did instead is I moved the -2 over. That's right. That's what this was here for. Since this is negative, I went ahead and moved that over, but I flipped it over.
got it,
I
got it.
know I should have wrote 3 equals 2x to show you that I did, but we put the x's to one side. But yeah, if I did the other way, if I subtracted 3 both sides, I got to change the signs. So 2x equals +3. Okay, now look at the multiplicities. The multiplicity of this first one is 3. The multiplicity of the second one is 1. If we add them together, we get 4, which is what that is. So what happens to the graph at this one? Does it bounce or does it cross?
It's it's odd, so it would cross.
Yes, it would cross. So we know it's going to go up across the x-axis, and same with the other one. So it's going to cross. So it'll look something like this. Follow those steps so far? This is what
Yes.
we just talked about earlier, is once we find the x-intercepts, we know what n and a are. So at those, we know the directions of the endpoints. We know if it's going to cross or bounce at that intercept. So we know the graph's going to look something like this. But let me show you the way that they're going to try to make you graph it, which is very labor intensive. This is example 2. H of x equals -2x to the 4 plus 3x cubed. As with all of them, we have to factor them out. So that part's the same. 2x plus 3. We have to get the x-intercept, so that part's the same. So we get x equals 0, x equals 3 over 2, or 1/1/2. Now, if we were to look at this on a graph, we have 0 there, we have 1 and 1/2 there. So what they're going to want us to do they want us to look at the interval from negative infinity to 0, from 0 to 3 over 2, and then from 3 over 2 to positive infinity. Get that so far? But I'm looking at this interval, and that interval.
Yep.
Now, what I want you to do here is pick a test value from each of these. So let's say this one, x equals -1. This one, x equals +1. And x equals 2. Just get a number of something in that interval. And what do we do with these? Because now we're looking at this side, this one here. The function value. So what you're going to do here is you're now going to put those values inside your function. Remember, our equation was -2x to the 4th plus 3x cubed. So if we put a -1 in there, what do we get? We got -2 times -1 to the 4th, 3 plus 3 times -1 to the cubed. -1 to the 4th is 1. -1 cubed is -1. So it's -2 times 1 is -2. 3 times -1 is -3, so it's -5. Let's do the same thing in the other two spots. -2 times 1 to the 4th plus 3 times 1 to the 3rd.
I see what you're saying about this being a lot more labor intensive.
Yeah, and here's the part that's going to show you how stupid all this stuff really is. Well, it does give you points, actual locations on the graph, yes, but the whole reason they're doing this is to tell you what side of the x-axis is the graph going to be. So this one's 1 to the 4th is 1, so it's -2 times 1. 1 to the 3rd is 1, so it's -2 plus 3 is +1. And the last one. Yeah, it's just and the bigger the equation, the more factors you have, the more painful it becomes. So 2 to the 4th plus 3, 2 to the 3rd. 2 to the 4th, 2 times 2 times 2 times 2 is 16.
Plus
2 to the 3rd is 8. So -2 times 16 is -32. 8 times 3 is 24. So it's -8. All they're looking at here are the signs. What the signs tell us? This one's negative, this one's positive. So in this first interval, the graph is below the x-axis for all the points on that side of that dot. Between these two dots, they're in the positive area. In this last one, they're all in the negative area. That's all this work was to show us, is what part of the x-axis and the y-axis do we put these graphs in? Again, my way that I showed you is much easier, much faster. Because once you understand what the degree and the leading coefficient tell you, what the end behavior, it's just a matter of just looking at the function. It'll tell you what to do.
Yeah, it also has a lot of parity with like the plug and play methods that you've been teaching us this whole semester.
Yeah, exactly. Yes, yes, very much so. Let's let's look at. Let's just do a couple of examples here. Example 3. Graph this polynomial. F of x equals x to the 4 minus 7x cubed plus 12x squared plus 4x minus 16. Yeah, I wouldn't give you this, but I will give you the factor. But think about this. At the end of next week, I can give you something like this, and you're going to be able to find the 4x intercepts because it's a degree.
Hmm.
So you're going to be able to figure this out. So the factors that we're going to have is x plus 1, x minus 2, x minus 4, and x minus 2. We're just supposed to graph this function.
So our x-intercepts are -1 to +2, +4, and +2 comes up twice, so it's only 3 points instead of 4.
Yes. So before we go any further, this is going to be important to us. Because these two are the same, I could put them together. So my degrees, my multiplicities are 1, 2, and 1. If I add them together, I get 4, which is what my degree is. So you're right. Our x-intercepts are going to be -1. X equals 2. And x equals +4.
And
Okay?
our a value is positive with,
+1.
yep, with an even n, so both ends will be going up.
Exactly. So at the endpoints, we know that they both go up. Now, at this one, at -1, does it bounce or does it cross?
So our multiplicity is odd, so it crosses.
It crosses, very good. Remember, also our y-intercept is -16. So it's going to cross there. What's it going to do at 2?
Uh, that one is even, so it will bounce.
Going to bounce. So it comes up here and bounces. And that +4,
It will also bounce.
nope, it's an odd
Oh, odd
odd
multiplicity.
multiplicity. So that's what the graph's going to look like. Again, you can't believe how much work I just saved you, because think about this. We have one, two, three, we have four intervals. We'd have to find the intervals, we have to pick the values, plug the values inside this function, determine if it's positive or negative, and that tells you if the graph is above or below. I just saved you a whole bunch of time by showing you this shortcut.
I would believe it actually because I have both of these two pieces, these two examples on the same sheet of paper, and I can see how much space they each take up.
Oh yeah, it's ridiculous. All right, the last thing in this section is called the intermediate value theorem. This is a theorem, which is actually it's very important. It's we also discuss it in calculus. But what this thing tells us is this. If you have a function, f of x, and it's continuous, on some domain. So here's A, here's B. And so it has to have a point at both ends. And there can't be a break anywhere inside there. So it has to be continuous on A and B. The intermediate value theorem tells us this. If we look at the values at both ends, and if, let's say this one is positive n, and this one is negative m. So this is positive n. This number here is at negative m. Because we took the endpoints, because they have opposite signs, there must be at least one x-intercept between or in that domain. In other words, what it says is if one side's positive, one side is negative, then there has to be a point in there somewhere where the function is equal to 0, the x-intercept. That's what this theorem tells us. It doesn't tell us how many, and it doesn't tell us how to find them. It just tells us one exists. At least one exists between those 2 points. That's the intermediate value theorem. Example 4, using the intermediate value theorem. F of x equals x cubed plus x squared minus 6x for the domain -4, -2. Okay, what this thing looks like on a paper, I would normally give it like this. But what this means is A equals -4 and B equals -2. But that's what it means here, is the domain of that closed interval. So what do? Plug these into our function, f of -4. -4 cubed plus -4 squared minus 6 times negative 4. Negative 4, or negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. Negative 4 squared, negative 4 is a positive 16. Negative and negative makes it a positive. 6 times 4 is 24. Sixteen plus 24 is 40. So negative 64 plus 40 is negative 24. So this one has a negative sign. Now let's try it at negative 2. So that's going to be negative 2 cubed plus negative 2 squared minus 6 times negative 2. Negative, negative, negative makes it negative. 2 cubed is 8. Negative 2 squared is 4. Negative times negative is positive. 6 times 2 is 12. 12 plus 4 is 16. 16 minus 8 is 8. And this one's positive. So this one's negative, this one's positive. So there is at least one x-intercept. Which they call a real zero between A and B. So simply because they have opposite signs and they're in that domain, that means somewhere between there, it has to cross the x-axis. Okay, let's look at the next one. The same function, x cubed plus x squared minus 6x on the interval -1, 3. So plug in 1 and plug in 3.
Wait, wouldn't we be plugging in -1?
Yeah, -1, yes. I have right there, yeah. Minus 6 times -1. 3 cubed plus 3 squared minus 6 times 3. -1 cubed is -1. -1 squared is 1. Negative is a positive 6. So the ones cancel. It's a positive 6. Three cubed is 3 times 3 is 9 times 3 is 27. 3 squared is 9. Positive is negative. 6 times 3 is 18. 27 plus 9 is 36. Minus 18 is positive 18. They're both positive. So the intermediate value theorem doesn't tell us anything. I mean, there's two more with fractions. If you want me to do those, I can do them. If not, then it's just that's what it's here to show you is you
I
plug in the
struggle
endpoints.
I struggle with fractions, so I would like to see those.
Oh yeah, okay, that's all. Yep, not a problem. So we're going to use g of x equals 1/3 x to the fourth minus x cubed on the interval -1/2 to +1/2. This is A and this is B. So let's look at the first one. Plug in A. Let's do g of -1/2. 1/3 times -1/2 to the fourth minus -1/2 to the cubed. Order of operations. We have to do exponents first. The rule is this: if we have a fraction raised to some power, we can distribute that power to every term or every element inside that parenthesis. So if it's x over y to the power n, the same thing as x to the n over y to the n. If it's x times y, z times p to the power n, then each element gets that exponent. So inside the first example, first off, is it positive or negative? Negative, anything to the, if it's an even power, negatives become positive because negative times negative is a positive. So this it's going to stay, it's going to become positive. I have 1 to the fourth over 2 to the fourth. Now, the next one, since it's a negative sign to an odd power, it's going to stay negative. It's going to be 1 cubed over 2 cubed. One to the fourth is 1. 2 to the fourth is 16. A negative times a negative is a positive. 1 cubed is 1. 2 cubed is 8. Okay. Now, we know since we're adding and subtracting fractions, we have to have a common denominator.
Right.
So, well, here we can see that 16 is made up of 2 times 8. So they both have an 8 in common. All they need left is 3 times 2. So we just need a 6 over 6. So it's 1 over 48 plus 6 over 48. You see how I got that? Because if I can make the denominators look the same, then I just get it to be the same. And then whatever I'm short, multiply those top and bottom. That's one way of doing it. Then we see the answer here is 7 over 48. Because we add the top numbers.
7 over 48.
So yeah,
Man,
since you have a common denominator.
I'm glad that I asked you to do these.
Let me show you the other way of doing these. At this point here, we had 1 over 48. So in this side here, we had 1 over 3 times 1 over 16 plus 1 over 8. Combine these two, 3 times 16 is 48. And we can always use the butterfly method. And we'll see what the problem is with this one. So 1 times 8 is 8, plus 48 plus 1 is 48 times 1 is 48. So we got 8 plus 48. Here's the problem. Now we have to multiply the bottom. 8 times 8 is 64. 8 times 4 is 32, plus 6, 38. So you see, it's just a lot of extra work. But if it's small numbers, the butterfly method is pretty short and sweet. So here are two different methods you can get. Eventually you get the same answer, but if we do it this way, we'll get 56 over 384. What do they both have in common? They both have a 2 in common. We keep on doing that a whole bunch. And
Yeah, but
eventually
it's
we
a
get
lot
a lot of
faster
extra
this
work.
way.
Yeah.
Yeah.
So yeah, if it's a bunch of small numbers, then use the butterfly method. But it's just we had the 16 here made it horrible. So there's your answer.
Is it so that, like me asking this might be a very lazy inclination. Feel free to tell me if it is. But if that's our answer for -1/2, is our answer for +1/2 the same but with a negative sign?
No,
Okay.
I'll show you why. It would happen. Well, actually, that's a great question. And see if you could answer this out. What kind of function would it have to be if I plug in the same numbers with different signs and it gives you the same answer?
Oh,
An even function. For example, if I had x squared, it's an even function. If I put in a negative or if I put a positive, it'll give me the same y value. And that only
uh,
works for even functions. Is our function odd, even, or neither?
um, is it neither?
Well, yeah, because this one's even,
Yeah.
this one's odd, it's neither.
Okay.
So we can't just change the signs of the answer. Remember, if it's an even function, it can only have an even exponent and or a constant number. If it's an odd, it can only have odd exponents.
Right.
So since this one has both, it's neither. So let's plug in g of 1/2. We have 1/3 to the power 2, 1/2 to the power 4 minus 1/2 to the power 3. So the 4 goes in both of those. So 1 to the 4th is 1. 2 to the 4th is 16. 1 to the power 3 is 1. 2 to the power 3 is 8. Can you see what was different there?
Um,
Because
mm,
since the second term was an odd term, it had minus in front of it, negative number cubed stays negative.
negative.
Negative negative becomes positive. The odd number changed the sign between these two.
Oh, yeah, it did. All right, you're right. Cool.
So you have 1/48. Remember, we did this one 6/6 minus 6/48. So the answer is 1 minus 6/48, which is negative 5/48. So let's look at those, the same function, but without fractions, with some regular numbers. On this interval, so g of 1 and g of 2.
So the first one just ends up being 1/3 if it's g of
1/3
1.
minus 1. If it is minus
Oh, right,
the
because it's
1
1/3
cubed.
times
Yeah.
1. Yeah.
And the second one is 1 to the third power is 1, so it's 1/3 minus 1, which is, we have to get a common denominator. So this one is 1 is written as 3/3. So that's 1 minus 3/3 equals negative 2/3.
And if we put 2 in,
1/3, 1/2 to the fourth, minus 1/2 to the third.
wait, I thought why are we putting it as
Oh,
1/2?
2. What am I 2? Whoa, we can get away from fractions.
It's almost like it's 3 o'clock in the morning where you are.
Well, actually, it's almost is, because I started, we just had another time change flying in. And so, yeah, we're now only, we lost an hour, so we're 14 hours. Because we're a day ahead of you guys, which is so cool. Anyway,
It is cool.
2 to the fourth is 16. 2 to the third is 8. So it gives us 16 times 1 is 16/3 minus 8/1. Get a common, oh, should we use, no. Oh yeah, we could use this. We use the butterfly, it's pretty short. So we get 1 times 16 is 16, minus 3 times 8 is 24. So it's 16 minus 24/3 times 1. So it's negative 8/3. They're both negatives. So I can't use that rule. So the mean value theorem won't, or the intermediate value theorem won't help me because they're both negative. Intermediate value theorem doesn't help here because they're both negative.